Alrighty, so hello everyone. Welcome back to the course. We're moving on, and we are in roughly the second half of this course. So, um, we're gonna kind of be reaching the part twos of this class. So, as we move into part two, let's just go ahead and get into CodingBat. So, make sure you're logged in. And so we've gone over these 5 sections. So these 5 were pretty easy. We might go back to warm-up 2, as some of the ones later on were a little more challenging, and if we finish these up and we still have time, we can definitely go back to this. Now, so we just finished up Logic 1 last week, so we're going to be moving on to Logic 2. So, for every single one of these questions, the thinking pattern is going to be almost the exact same, except with probably larger sets of data, more complicated sets of data. So as we can see, there's 7 questions here, so we're probably going to be spending 2 weeks on this. So this class, we're going to do the first 3 questions, maybe even 4, and then the next class, we're going to go over the second half. So without further delay, I guess let's get started on the first question. So the first question is make bricks, and Pranav is going to be teaching this one. So, alright, you can go ahead, Pranav.
Okay, we got Logic 2 Problem 1, make bricks. So like usual, I'll give you some time to read the instructions because these ones are a little bit harder, so pay attention. Okay, so at the end of the instructions, you will see something that says, see also Introduction to Make Bricks. When you click on this, you'll go to another tab. This tab is where the creator of CodingBat walks through the thinking of this problem. So if you still don't understand, even after I teach you how to do this problem, I recommend you to watch the video there and do the practice problem on that tab. So now let's go over the instructions. It says, we want to make a row of bricks that is goal inches long. We have a number of small bricks, 1 inch each, and big bricks, 5 inches each. Return true if it is possible to make the goal by choosing from the given bricks. This is a little harder than it looks and can be done without any loops. Okay, so what this means is that we have small bricks, which are each 1 inch long, big bricks, which are 5 inches long, and we have a goal number of inches, so that's what we want to achieve. So we return true if we can meet the goal number of inches with the number of small and big bricks that they give us. And when we can't meet the goal, we return false. So we have 2 conditions that we have to meet, true and false. So you know what that means. We could use an if and else statement, if else statement here. So let's make the if portion result a false and the else portion true. And when we cannot reach the goal, that means that the inches of the small bricks and the inches of the big bricks combined is greater than the goal. So that's what I did here. So I said if the goal is greater than the number of small plus the number of big, but then here I did times 5. So why did I do times 5? you have to remember that the big bricks are 5 inches each. So this one would be 1, and this one is not 1, so we would have to multiply it by 5. So at the end of the if, we return false because that's the condition. So this means it doesn't, you can't fit the small brick in the big bricks with the goal. So now let's do the else or the true section. Basically what I did here was return goal modulus 5 when less than or equal to small. So if you don't know, remember what the modulus symbol means. It gives us the remainder when the first operand is divided by the second. So this means when the goal is divided by 5, and when this remainder is less than or equal to small, we return the other condition, which is true. So how about we try this out in the examples below, above to see if this works out. So we would have the goal in this example here, which is 8. And when we divide it by 5, it gives us 3. And is 3 less than or equal to small? Yes, it is, which means that it will produce true. And let's try the next one. When we divide 9 by 5, what is the remainder that we get? We get 4. Is small greater than or equal to 4? No. So it will produce false. We'll go to the other condition. Now let's do this last example. When we do 10 divided by 5, we get 2. And is that greater than 3? No. So we would do small. We would do true, sorry. So now that we know that it works out, it's time to test it out. And we click go. And when we click go, we get all green. Yeah, so that's it of make bricks problem 1. Now let's move on to problem 2.
Alrighty, let's reopen our coding bat up. Okay. So we just finished going over make bricks, which is right here. And so now we will be moving on to loan sum. So loan sum, the instructions are quite simple, and they have 3 different cases that we can go over. Now, don't underestimate these instructions because although it looks pretty simple, it's not actually that easy. So I'll give you a little to think about it, and then we'll go over it. So now that we're back, so first thing is we need to just define lone sum right here. Whoops. And so we need to make sure that we have the correct parameters. So that is our beginning method. So let's read over the instructions, right? Given three integer values, a, b, and c, return their sum. However, if one of the values is the same as another of the values, it does not count towards the sum. So we can look at these over here. We see 1, 2, 3. None of them are the same, so we get 6. Now we have 3, 2, 3. And for 3, 2, 3, we see that there's a matching one between A and C. And because A and C are the same, they are excluded from the sum. And since they're excluded from the sum, the entire sum of this expression is just going to be 2. Now we have a case where all three of them are equal to each other. And since all three of them are equal to each other, none of them will contribute towards the sum. And as a result of that, the sum is simply 0. Now, when we go ahead and we start writing our code, we need to think about, well, how do we exactly split up our cases? So I want you guys to take a second and think of all of the possible cases when we write out this program. Alright, so now that we've thought of our cases, so let's just go over them real quick. So this one has a couple of main cases. So our first one is going to be when all of them are not equal to each other, right? So we just obtain the regular sum. Now our second case actually has many different subcases, right? So our second case is when two of the numbers are equal to each other. So that can be either the first and second number, first and third, or second and third. So that brings us 3 different cases, right? And our last case is going to be when all 3 of them are equal to each other. So we need to make sure that we account for all of these. However, going ahead and hard programming it isn't always the right way. But since this is a logic problem, we can go ahead and start off with that. So our first case is going to be, the one that we first consider is going to be kind of when all 3 of them are equal to each other, because that one's easy to cancel out. So we write our if statement. If A is equal to B, and if the stream just crashed right now, OBS Studio just disconnected and reconnected. I'm not entirely sure what that's about, so I'll go back a couple of seconds. So essentially, our if statement right here is if A is equal to B and A is equal to C, then that means that B is equal to C. And now that we know if all 3 of them are equal to each other, then we just get 0 no matter what A, B, or C are equal to. So next off, we have to think about, alright, what's our next case? Well, if either one of them are equal to each other, then that means that we return the one that is not equal. And the reason why we can do this, and we don't have to check if that last number is equal to the others, is because this first case already takes care of it. So we can just write elif or else if A is equal to C, then we go ahead and return B. Similarly, if B is equal to C, then we return A. And then we need to make sure that we go ahead and we write our final one of these cases. Remember, we have 3 of these. So we have A is equal to C, B is equal to C, so now we need to go ahead and do A is equal to B. Then we go ahead and return C. And our final case is when none of them are equal to each other. It's regular addition, so all we need to do is just return A plus B plus C. So we can run that code, we get our solution. It's pretty long though, so we're gonna think about how we can simplify it, but for now just go ahead and think about this code, and also make sure when you think about it, think about how long it takes for you to kind of run through all this code, and then we can compare it with our later results with our code. Alright, so now that you hopefully have gone over it, so next thing that we need to do is we can see, well, all the cases that we have over here seem to be pretty simplified already. There's nothing like simplifying if statements. There's nothing like reducing our return statements. Obviously over here we can do that and we can simplify the code a little bit more, right? But overall, it seems like we have everything down already, right? We take care of each case individually. There's not really a way to simplify these cases because they all return different numbers, right? This one will return 0, this one returns B, A, C, and then A, B, and C. Now, this is where things get a little tricky. Since this is a slightly more complicated logic problem, we need to start thinking from a different perspective. Now if we think, so originally we started from our base case of 0. And when we return our base case of 0, it kind of helps eliminate some of the other options for the rest of the cases that we go over. However, there's a slightly more efficient way we can use this method. Now, if we delete all of this code and we restart our logic, so we think, okay, well, we're going to actually just go ahead and return sum. So our last piece of code is going to be return sum. And then we need to think, alright, well, how do we make sure we only add the numbers that we need to add? Well, remember, as long as that number is not equal to any of the other numbers, then we can add it to it. So, if A is not equal to B, alright, and A is not equal to C, then sum A gets added to sum. Alright, so we can do this with not just A, but we can do this with B and C as well. So we can go ahead and we get if B is not equal to A and B is not equal to C, then sum plus or equal to b, so b gets added to sum. And finally, we get if c is not equal to b and c is not equal to a, then we can do sum is plus or equal to c. So we have this code, and if we run it, we can see that we get all the cases, right? So there's actually something that we can simplify this down even more. So this is known as like a one-line if statement. So typically, when you think of an if statement, you think of this if part over here, and then you return whatever you need to up here. Now, what you can actually do is you can just entirely remove that return right there, and you see it still runs perfectly fine. So we can do that for every single one of these, and it will run perfectly fine. So the logic still remains the same, but we can see that we shrunk down that almost probably 9 to 10 lines of code down to only a couple, so 5, right? Basically halved. So I want you guys to think about how we were able to do this, and then I want you guys to make sure you guys understand the code here. So hopefully you guys understand this. Now, one thing that I want to point out is you may notice, well, A is not equal to B and B is not equal to A seem like the exact same statement except flipped around. Now you may be wondering, well, why can't we just go ahead and delete this statement entirely? Because this already covers the A is not equal to B statement. Well, we have to think about one thing. When we remove A, in the case that A is equal to B, all that's removed is A. Now we go ahead and we remove this statement. B is no longer removed. So we always need to remember to double check, right? So for every single one of these cases, we have to do a run through. So that wraps up lone sum. So the next question we're going to be doing is lucky sum. So Daniel will be doing this question. So let's open that up. Alright, Daniel, you can go ahead.
Okay, so this question is called lucky sum, and the description is given three int values a, b, and c, return their sum. However, if one of the values is 13, then it does not count towards the sum, and the values to its right do not count. So for example, if b is 13, then both b and c don't count. I'm gonna give you guys a couple, like 30 seconds to understand this. Okay, so here we have, in the first one, we have 1, 2, and 3, and we get 6 because it counts all of these numbers, and they add to 6, and we get this. And here we have 1, 2, and 13, and that gives 3 because in the description it said that if one of the values is 13, then it does not count towards the sum, so 13 does not count. So in the last one we have 1, 13, and 3, and we would get 1 because the value of 13 does not count and the values to the right of 13 do not count either. So the way I would approach this problem would be to think of an idea first and then write that idea. So we want the sum of all three numbers first. So in the second case it would be 16. And then we want to subtract the values. We want to subtract any value of 13 if there is one, and all the values to the right of the 13 if there are any. So what we would start with would be sum is equal to a plus b plus c. And then we'd start off by writing an if a is 13. So if this first value is 13, then we would subtract all the values, and so basically we would return 0. Now if b was equal to 13 and a was not 13, we have to include this a is not equal to 13 because if we ran this code, if b equals to 13 and b was 13 but a was also 13, then it would not count the value of a, and it would count the value of a, and it would only subtract the values of b and c. So we have sum minus equals, and what this basically means is sum is equal to sum minus something. So you would write sum minus equals b plus c. So the value of b and the value to the right of b would not count. And then in the last one, it would be if c is equal to 13 and b is not equal to 13 and a is not equal to 13, then the sum would be the sum minus equals c. So it wouldn't count the value of c, but it would count the values of b and a. And then we would return sum, and it should yeah. And I'll give you guys a couple, like 30 seconds to understand this code. Okay, so this is the solution to lucky sum.
Alright, so we went over the first 3 questions of Logic 2. So I want you guys to go over the questions yourselves and re-watch this if you have to, and make sure you truly understand this stuff, because although this seems to be testing very basic concepts, making sure that you're actually able to consistently be able to kind of program these without any mistakes in them. Obviously some like small syntax errors, like forgetting like the second equal in an equal equals, that's perfectly fine, but make sure that you have the logic down, because many times the logic can be quite confusing in problems, and practicing it is, especially through CodingBet, is a great way to do this. So if anyone has any questions, please feel free to ask them right now, and if not, then thank you for watching, and we'll see you guys next week. Alright, it looks like no one has any questions, so thank you, Aaron, and bye.